Okay. At some point, within the next like hour or so, I'm gonna have to do some laundry. I'm gonna have to put this bedding on my bed. But aside from that, there's nothing else really going on. Um, Look at that though. Isn't that interesting? On the mattress cover, there's like a thing going on. Do you see that? Isn't that crazy? Um, but okay. Okay. I'm also doing cat UI on Helium because look, they fixed it. They fixed it last update. The extensions, pinned extensions don't go away when you add new tabs, which is very exciting. I don't know if I like the idea of like having so little tab space. Like, they start getting, you know, shortened as soon as you have even 4 tabs, you know, on a half window. So I don't know if it's great for productivity, but if you only have a few tabs open, and frankly, you probably should. You should get into the habit of maybe this will get me into the habit of closing my tabs regularly, because maybe that's the problem. Like, frankly, you know, maybe this is a fine UI, and it's just like I should just close my tabs more. But quality of service. What does it provide? It provides information. Does IPv6 handle packet fragmentation differently? I'm gonna have to guess it increases the MTU. Requires the host to perform path MTU discovery. Okay, so the difference is that, does this mention routers? Requires the host? That's strange, because here it says it was originally intended for routers in IPv4, however all modern operating systems use it on endpoints. I guess I don't necessarily know what endpoint means. Use it on endpoints? All modern operating systems, presumably that means desktop operating systems, right? Like Windows or I guess also like server operating systems. Like, I don't see why they wouldn't do PMTUD, right? But what do you mean use it on endpoints? In IPv6, this function has been explicitly delegated to the endpoints of a communication session. Okay, sure. So do the endpoints mean the host? Like, like say a host is trying to communicate with a host on another LAN, like does IPv6 sort of explicitly delegate the 2 endpoints to like use path MTU discovery? As an extension to the standard path MTU discovery, a technique called packetization layer path MTU discovery works without support from ICMP. Sure. For IPv4 packets, path MTU discovery works by setting the don't fragment flag in the IP headers of outgoing packets. Then, any device along the path whose MTU is smaller than the packet will drop it and send an ICMP fragmentation needed type 3 code 4 message containing its MTU, allowing the source host to reduce its path MTU appropriately. The process is repeated until the MTU is small enough to traverse the entire path without fragmentation. As IPv6 routers do not fragment packets, there is a don't fragment option in the IPv6 header. Why would you need that option? Why would you need this option if it's using IPv6? For IPv6, path MTU discovery works by initially assuming the path's MTU is the same as the MTU on the link layer interface where the traffic originates. And the link layer, that's So there's physical and then there's data link, which is like where it connects to the router. So that would be like a switch or something. Then, similar to IPv4, any device along the path whose MTU is smaller than the packet will drop the packet and send it back an ICMP v6 packet to big message containing its MTU. Okay. Allowing the source host to reduce its path MTU appropriately. The process is repeated until the MTU is small enough to traverse the entire path without fragmentation. If the path MTU changes after the first connection is set up and becomes lower than the previously determined path MTU, the first large packet will cause an ICMP error and the new lower path MTU will be found. If the path changes and the new path MTU is larger, the source will not learn about the increase, because all routers on the new path will be capable of relaying all packets that the source sends using the originally determined lower path MTU. Okay, because like if the MTU gets larger, it's fine because you're just sending like low MTU packets. Okay, sure. Do I need to read the problems? I see. Okay. So I'm gonna. Yeah. This person is asking my exact question. I can't really do this because I have it set to where bookmarks are disabled unless you're on a new tab page. Dude, okay. I guess it'll have to deal with the citations. This is the Wikipedia page regarding path MTU discovery. I noticed that it talks about how IPv6 routers don't fragment packets, explaining this as the reason why there's a don't fragment option in the IPv6 header. However, if IPv6 routers don't fragment, why have the option in the first place? Isn't it implied by the fact there's an IPv6 connection? Is this... Okay, sure. But I think you might... Oh my god. It's over. It's over for me. That's so embarrassing. Okay. You know, I think that sort of thing is why people don't live stream themselves learning. Okay, cool. Cool. Yeah, so the IPv6, how does IPv6 handle fragmentation differently? Okay, yeah, so this is super wrong because this doesn't even this doesn't even like happen. This isn't a thing that happens with like MTU discovery stuff, even on IPv4. Like they don't increase the MTU. Like it's not a problem if the MTU is too small, right? Like that's never an issue. The issue is only if the MTU is too big and it can't handle that, and so it has to decrease. And it's never increasing the MTU, I don't think. Requires the host to perform path MTU discovery. Okay, I think the problem here is that I just don't know how... Well, I don't know enough about how IPv4 handles packet fragmentation. I guess I could ask. Or... Oh, wow. Under IPv4, a router that receives a network packet larger than the next hop's MTU has two options. Drop the packet if the don't fragment flag bit is set in the packet's header, and send an internet control, send an ICMP message which indicates the condition needed, or fragment the packet and send it over the link with a smaller MTU. Although originators may produce fragmented packets, IPv6 routers do not have the option to fragment further. Instead, network equipment is required to deliver any IPv6 packets or packet fragments smaller than or equal to 1,280 bytes, and IPv6 hosts are required to determine the optimal MTU through path MTU discovery before sending packets. Okay, so if the MTU is too small, IPv4 can fragment the packet, so it can go into multiple packets. But this doesn't happen with IPv6. The thing that happens is... Okay. Sure. Okay, so... Thank you to... I don't know why I noticed that, but thank you to whoever is pressing the heart button. And it tries it, and if it doesn't work, it goes... Okay, and then let me send... That's fine. I'm okay with screenshotting something twice. Let's see if this is, like, fairly accurate enough. Oh no. One specific detail. Here's a breakdown. Why that flashcard answer is the right one. In IPv4, the sender... Okay, wait. Ask what the other host what the MTU should be. It's more aggressive. The host doesn't politely ask the destination, it just sends the packet. The router drops the packet. Okay, and then the router sends a packet too big message, and then it adjusts it down. So it doesn't like ask it what the MTU. Okay. Okay, and then I'm pretty sure this is explicitly mentioned in here. Yeah. Any device along the path whose MTU is smaller than the packet will drop the packet and send back an IPv. ICMP6 packet too big message containing its MTU. Okay, so the MTU is inside of the message. Okay, so it might be like, oh, you're almost there. So that I might have to point that out there. Okay. Okay. Cool. Okay. Writing a program for exchanging video files through a TCP/IP network. Which TCP you will select a transfer protocol that will guarantee delivery. Is TCP/IP not? Is it not a transport protocol? Okay. I'm inclined to just say TCP because this appears like a really silly like CompTIA question and answer type thing. I know it's not UDP because that has nothing to do with the question, and it's also not what you want. Wait. No, it's not what you would wait. Yeah, it's not what you would want. So I feel like it's either FTP or SIP, and I don't really know what SIP is. I know FTP is file transfer protocol. Exchanging video files. It doesn't talk about streaming video files, which I think is the reason why it's not UDP. Is video streaming done over UDP? I'm actually not sure. Because there's buffering, right? It buffers ahead. And the video stops if it stops. I'm actually not sure. Okay. It's talking about exchanging video files. I don't know what SIP is. It's entirely possible this is the answer, and if I knew what the acronym meant, it would like be super obvious. But I'm gonna go for FTP because it's for exchanging files. TCP? Okay, that's crazy. I feel like this is obviously a silly question. Oh wow. I can't believe it. person in chat. It's just crazy that it says. I just thought it couldn't possibly be TCP because it mentions TCP twice in the question. And why would you have the answer in the question twice? Like, that's bonkers. But I guess I was wrong. Okay. What's the purpose of a net mask? A network mask? Like a subnet mask? I'm gonna go for 3. How can you direct a dig query to a specific DNS server? I feel like it's not 3. Dig. I'm trying to remember the dig syntax. Okay, I don't think 4 is correct. It's okay, wait, it's gotta be 1. Okay. Border Gateway Protocol. Okay. BGP is a standardized exterior gateway protocol designed to exchange routing and reachability information among autonomous systems on the internet. BGP is classified as a path vector routing protocol and makes routing decisions based on paths, network policies, or rule sets configured by network admin. Okay, is there like a... BGP neighbors called peers are established by manual configuration among routers to create a TCP session on port 179. A BGP speaker sends a 19-byte keep alive message. Sends 19-byte keep alive messages every 30 seconds to maintain the connection. Among routing protocols, BGP is unique in using TCP as its transport protocol. Okay, so I wasn't. Okay. I shouldn't make excuses. When BGP runs between 2 peers in the same autonomous system, it is referred to as internal BGP or IBGP. When it runs between different autonomous systems, it's called external BGP. Routers on the boundary of one autonomous system exchanging information with another autonomous system are called border or edge routers, or simply eBGP peers, and are typically connected directly, while IBGP peers can be interconnected through other intermediate routers. What? Routers on the boundary of one exchanging information with another AS are called border or edge routers. Border or edge routers or eBGP peers. Okay, I feel like this should be like a border, comma, edge routers, comma, or simply E. Because this is the least simple descriptor. Okay, and are typically connected directly. I don't know what connected directly means. While IBGP peers, which is internal BGP, are interconnected through other intermediate routers. Dude, I feel like Wikipedia isn't the best source for this. Yeah, maybe Cloudflare. Yeah, this is so much more explanatory than the Wikipedia thing. I remember seeing like a tweet or like a YouTube video or something about how a lot of Wikipedia pages on like technical subjects are very dense and are written by experts. You can say. Um, sure. And is therefore the quickest, most efficient route. Now imagine that there are hundreds of thousands of autonomous systems and hop count is only one part of a complex route selection algorithm. That is the reality of BGP routing on the internet. The structure of the internet is constantly changing, with new systems popping up and existing systems becoming unavailable. Because of this, every autonomous system must be kept up to date with information regarding new routes as well as obsolete routes. This is done through peering sessions where each autonomous system connects to neighboring autonomous systems with a TCP/IP connection for the purpose of sharing routing information. Using this information, each autonomous system is equipped to properly route outbound data transmissions coming from within. Here's where part of our analogy falls apart. Unlike post office branches, autonomous systems are not all part of the same organization. In fact, they belong to competing businesses. For this reason, Border Gateway Protocol routes sometimes take business considerations into account. Autonomous systems often change each other to carry traffic across their networks, and the price of access can be factored into which route is ultimately selected. Autonomous systems typically belong to ISPs or other large organizations, such as tech companies, universities, government agencies, and scientific institutions. Each access system is wishing to autonomous system is wishing to exchange routing info that must have a registered autonomous system number, an ASN. IANA assigns ASNs to regional internet registries, which then assigns them to ISPs and networks. ASNs are 16-bit numbers between 1 and 65,534, and 32-bit numbers between 131,072 and 4,294,967,294. As of 2018, there are approximately 64,000 ASNs in use worldwide. These ASNs are only required for external BGP. Router exchange and traffic is transmitted over the internet using external BGP. Autonomous systems can also use an internal version of BGP to route through their internal networks, which is known as internal BGP, iBGP. It should be noted that using internal BGP is not a requirement for using external BGP. Autonomous systems can choose from a number of internal protocols to connect the routers on their internal network. Okay, so you can do iBGP if you want. External BGP is like international shipping. There are certain standards and guidelines that need to be followed when shipping a piece of mail internationally. Once that piece of mail reaches its destination country, it has to go through the destination's country local mail service to reach its final destination. Each country has its own mail service and does not necessarily need to follow the same guidelines of those other countries. Similarly, each autonomous system can have its own internal routing protocol for routing data within its own network. BGP tries to find the most efficient path for network traffic. As noted above, the hop count is not the only factor BGP routers use for finding those paths. BGP assigns attributes to each path, and these attributes help routers select a path when there are multiple options. Many routers allow administrators to customize attributes for more granular control over how traffic flows on their networks. Some examples of BGP attributes are weight, which is Cisco proprietary, local preference, originate, autonomous system path length. Okay, sure. Several other BGP attributes ordered by priority, so checks first, highest weight, then checks local preference, and okay. I see. Okay. So does the Wikipedia article make more sense now? BGP neighbors called peers are established by manual configuration among routers to create TCP session. BGP router since okay. Among routing protocols, BGP is unique. When BGP runs into two peers in the same autonomous system, runs between two peers in the same autonomous system, it is referred to as internal BGP. When it runs between different autonomous systems, it's called external BGP. Routers on the boundary of one autonomous system exchanging information with another autonomous system is called border or edge routers. Okay, does the stuff I've done answer my question? Oh yeah, it's about okay. I don't need to learn about the specifics of BGP unless other questions come up regarding it. Okay, I know how BGP works now, mostly. I mean, I know what it does, not how it works. All of which use Wi-Fi. The administrator wants to ensure the network provides the best possible performance for video conferencing and large file transfers. Dual band 802.11n access points. Which of the following configurations should the administrator prioritize to achieve the desired network performance? Best possible performance for video conferencing and large file transfers. Well, it's not one. I don't think it's two. That would be weird. I feel like it would be three because it mentions access points explicitly, and CompTIA likes that. And I don't know what HT mixed mode is, so presumably there's some sort of information regarding it that would expose it to be the answer. So I'm gonna go for three. Really? Enable channel bonding? Okay. I don't know what HT mixed mode is. Oh, okay, so it's like for legacy compatibility. That makes sense. So, I guess I know what channel bonding is, but I don't see... Okay, I guess that makes sense. Because best possible performance, you know, you would do channel bonding because that would, you know, maximize the amount of channels that an access point can use at once. I guess that makes sense. I just didn't think hard enough about it. Of course, the host... Hello? Two. TCP answers in the question, and then it uses TCP again, and then wow, I got so many wrong this time. Channel bonding. Four-pair mode in POE technology. Four-pair? The significance. What is the significance of four-pair mode? I'm gonna go for one, because that seems like it makes the most sense. But it could also be like a legacy compatibility thing. Okay. Purpose of HTTP headers. Installing a special driver. Rack containing equipment that draws 2,000 watts. Oh, wait, you just do math. Because I know wattage is just voltage times amperage. But I don't know exactly what VAC is, because I'm not... Sorry, I haven't looked into electronics. Sue me. Sorry, I'm not an electrical engineer. For a rack containing equipment that draws 2,000 watts, I mean, I'm inclined to say it would just be you know, 2000 equals 240 times x, right? I don't really know how I would do that because I'm bad at that sort of thing. Oh, would you just divide 2000 by 240? I guess so. Okay. .3. Okay, I'm gonna go for 2, but I think it might be a distractor for people who don't know what VAC is. Okay, I guess I was right. Which of the following is not a prime? You know, I don't know if I'll have a calculator during the Network Plus exam. Maybe I cheated that. Not a primary function of the service of a service level agreement. Not a primary function. SSH host key. I mean, I want to say it's for speeding up the SSH connection process, because if you give your host key to other people, it just automatically lets you connect, right? But that might not like used for. I don't know. I get its utility is to speed up the process. What? Do I not understand what an SSH host key is? Is a public key used to authenticate a host, allowing secure communications between machines. That's what I thought. Identifying the SSH server? That's so strange. Oh, I think it doesn't mean like, oh, this key is associated with this SSH server on this device. So please allow this SSH server that I've identified with this key. Okay, I guess that makes sense. I'll have to ask if that's correct. It does speed up the connection process. Though, looking at it more, it appears it might be referring to telling a remote host that your SSH server is safe with said SSH server running on your machine. In that way, an SSH server is identified as safe. Is that what this question means? I think I might have gotten that wrong. I think I might be mixing it up here. So like, I don't know if this is why this happens, you know? Like, I don't know if it's the keys being the same or what. Okay, I am right. What was it thinking for so long about? Okay. Cool. I guess that makes sense. Was it DHCP starvation attack? I don't think it's 1 or 2. I think it's got to be 4. Identifying the SSH server, which makes sense. What can cause convergence problems in a dynamic routing network? Requires 100 subnets? Oh god. 100 subnets? It requires a global routing prefix of that 48. God. What is the most appropriate subnet prefix length the admin should use to accommodate a company's requirements? So IPv6 address is 128 bits, right? So if a global routing prefix, so that's a 48-bit global routing prefix, and then 100 subnets. I'm gonna go for 52 because that's the lowest one, and 100 doesn't seem that high. Okay. A security engineer configures software-based port security on a hardware firewall. Software-based, so would that be the app? I want to say application layer because it says software-based port security on a hardware firewall. But the application layer is in here, so I'm going to go for layer 4 because it's the highest up. Okay. What is the key feature of routers, gateways, or VPN apps in a software-defined wide area network? They are SD-WAN capable, right? What is a classless notation 64 signify in the network, in an IPv6 network address? Hexadecimal notation. Hardware MAC addresses, that's true. Yeah. But it can communicate with other devices on the same subnet. IP address of that with that, and the default gateway is set to 01. That looks correct. Am I crazy? It's unable to access website. I guess the default gateway is probably wrong if it can't access stuff on the internet, but it can communicate with devices. Yeah, I'm gonna go for default gateway, but that seems really weird because usually 10.0.0.1 would be the default gateway address. Frankly, I think 1 is probably more reasonable than 4 because like why would the address not end with a 1? I'm gonna go for 1, not 4. Really? It's 4? Really? That's really strange. Oh, the network's default gateway is set to 10.0.0.1. It never said anything about the computer's default gateway. Okay, I see. Okay. Okay. Okay, I see. That makes sense. It never said anything about the computer's default gateway. Whoops. I should have read the question more closely. Telecommunications company wants to offer its customers customized network services such as optimized routing for gaming and high priority bandwidth for video conferencing. Which software-defined networking feature enables this level of service customization? I'm gonna go for that. Gas-based fire suppression systems such as clean agents. They don't cause significant water damage. What? Oh, I thought that said can't. Okay. No, I knew that was the case. I just thought that said can't. Whoops. What is the recommended practice when using SNMP v2c regarding community strings? The community string is unencrypted, right? On SNMP. Like, wasn't only SNMP v3, like, isn't that the only one with an encrypted community string? So I would assume secure environments only. Really, use difficult to guess? But isn't, does SNMP v3 even exist? Yeah, version 3. Yeah, it adds cryptographic security. I using that word properly? Okay, sure. Sure. I mean, it feels like it does feel like a cheap technicality, but I see the reasoning. And, you know, it is true that if you're setting up SNMP v2c, which you shouldn't ever, but it is true if you're setting it up, you should probably use a difficult to guess community string. But, like, what? Like, it really does, like, what? Like, just don't use it. Just don't, just use SNMP v3. I'm gonna guess expedited, maximum throughput. I don't even know what diff serve is. I've looked it up before, I think. It's a computer networking architecture that specifies a maximum for classifying and managing network traffic and providing QoS on modern IP networks. Diffserv can, for example, be used to provide low latency to critical network traffic such as VoIP or streaming media, while providing best effort service to non-critical services such as web traffic or file transfers. It uses a 6-bit DSCP and a 6-bit DS field in the IP header for packet classification purposes. DS field, together with the ECN field, explicit congestion notification, replaces the outdated IPv4 TOS field. Okay, sure. It's like an IPv6 thing? Most modern carry many different types of services, including voice, video streaming, music, web pages, and email. What is expedited forwarding? Okay, well now that I know what diffserv is, okay, sure. I guess I should just know these. Okay, that makes sense. Your company experiences a major power outage due to a severe storm, resulting in the loss of critical data center applications. You have a disaster recovery plan in place. Which of the following steps should be prioritized immediately following this incident? Immediately following the incident. It's not one. I don't think it's two. Oh, yeah. You're a network admin, mid-sized company, recently expanded its operations. The expansion includes the addition of new employees and the implementation of several new network applications to support business processes. Due to this expansion, you notice an increase in network traffic and occasional slow response times from critical applications during peak business hours. To address these issues, you decided to conduct a performance monitoring exercise to identify potential bottlenecks and areas for improvement. Which of the following performance metrics could be most useful in identifying the root cause of slow response times? To identify bottlenecks? I don't think it's one or two, because I don't know what storage capacity has to do with it, so it's either 3 or 4. So I guess the question really is utilization / throughput or bandwidth. Throughput has more to do with bottlenecks. I'm going to go for 3. Okay. Yeah. And use difficulty to X community strings, which you shouldn't use SNMP V2C. Not a traffic class. Maximum throughput. What is an extended service set? Middle of a big project at work. All your work files are on a server at the office. Oh, that's the dryer. I have to put my sheets on my bed. Be right back, everyone. I'm also probably going to get a little food, but I'm going to eat while I'm studying. Oh man, my microphone has been on. That's probably fine, but unexpected and irritating. Okay. Alas, alas. I wonder what the populace heard. Probably nothing, but I'm gonna be thinking about that. You know, I'm gonna be laying in bed and I'm gonna be thinking to myself, man, I wonder I wonder what these people heard. Like I don't think I said anything, but also like now I don't know. Like I wasn't paying any particular attention to what I was but yeah, I got some food. And I'm gonna be studying while I eat food. We're in the middle of a big project. Oh shit. Oh shit, I didn't cut this properly. But that would be remote desktop protocol. Channel link? It's not 1. I don't think it's 2. It's got to be 4 because the other ones don't make sense. Fiber strands using MPO connectors. I don't know. $16? Or, oh wait, because fiber, a lot of the time it's like it has like TX and RX, they transmit and receive. So maybe if it's 4, that would be like 1 transmit and receive, 2 transmits and receive, 3, 4, that would be 8 strands. I'm gonna guess 8, I could be wrong. Okay, that makes sense. Uses smart cards. Remote access authentication protocol allows the use of smart cards. I'm gonna assume something newer. Thanks CB Stalls for saying nice. Which remote access? I don't know. A newer one? I don't think it's PPP. I think PPP is pretty old, actually. I'm gonna go for chat. Okay, EAP. Writing the transport and usage of material. Dude. Okay, I guess it is called extensible authentication protocol. Smart card. Okay. Sure. Defines cash flows. Okay, so it like aggregates packets and then it puts it into a collector. So like, what does an exporter do? Defines cash flows. Cash flows? What do you mean? Sure. Okay, I guess that makes sense. Defines cash flows. That is like a pretty weird way to describe it, and it wasn't immediately obvious when I visited the Wikipedia page, which I think sort of implies that there's something wrong with the question or something wrong with the Wikipedia page, because I don't think I'm particularly I don't think it's particularly difficult for me to understand something as long as it's described well, But I think that might be the case for everyone, frankly. Maybe I'm, trying to set myself apart when really I'm just very average. To specify which network interface to listen on. For interface, what is the role of threat research in cybersecurity? Four. QSFP. Okay. Oh, it's like a type of SFP? Quad, small form factor pluggable. Okay. Oh, okay, I see. So QSFP is only for 4 gigabits, but you could do 40 gigabits with QSFP plus. Okay, that makes sense. By provisioning. Yeah, because why would it be 16? So it's extensible authentication protocol because it's extensible as in it can do things like smart cards. NetFlow exporter defines cache flows, which is a weird way to describe that, and that one. That's a peer-to-peer network, right? I would have said IP root show because there's the IP command on Linux, but this is referring to a router, and it could be like a Cisco router. So I don't think, and I think Cisco routers use show, like they go for show. I think it might be show route. I could be wrong though. Okay. Small business has recently expanded its office space to accommodate the expansion. The IT department decided to install several additional. Something up with my wheels? No, I think we're fine. It's just squeaky. To accommodate the expansion, the IT department has decided to install additional wireless access points. Intermittent Wi-Fi connectivity issues. What? It's interesting that they specified. It's interesting that they specified Cat6 cabling, but that could just be a distractor for this answer in particular. And I'm pretty sure the only difference between Cat6 and like Cat6a is that Cat6a is shielded, right?
So I'm going to go for place too close to each other because it's intermittent Wi-Fi connectivity issues. Like if it wasn't suitable for PoE, the things wouldn't even be on. What? Total power budget. Okay, I guess that makes sense because switches do have a power budget. But I was thinking signal interference was just more likely than that. Oh, okay. I see. Yeah, that does make sense. Because it wouldn't like intermittently turn off, it would have signal degradation if there was interference. Okay. You don't need to give me a metaphor. The first step in the lease process, I was thinking DHCP discovered because maybe that's what like hosts put out. But if it's the first step in the DHCP lease process, that implies it's after the DHCP process has been discovered. But also, why would it be oh wait, yeah, okay. DHCP lease, over request. Discover, really? I think I just don't have a comprehensive enough understanding of DHCP. Discover, offer, request, acknowledge, right? Okay. I was thinking the way this question was worded that it was sort of implied that we were already past the DHCP request process. The part of it where it's DHCP request, but you know, widget innovations. Clientless VPNs?
I didn't know that was a thing that existed. What? It's over. Man, thank you for the hearts. I keep messing this stuff up. Primary role? Really? It is not just the IPv6 equivalent of DHCP for IPv4. I see. I'm gonna finish this food really fast because it's getting cold. Okay, I'm gonna clean my plate and also take a quick break. such as cert infrastructure. I guess that makes sense because broadcast domains are like from routers, right? Or like not even that, but like a broadcast domain. Am I misunderstanding what domain means here? Okay. A controller. In managing overcapacity, I feel like it's either 3 or 4. I'm gonna go for 3 because that seems more realistic. Yeah. Narrowband? I think that means it's not very good penetration power, so I think it's not 2. Narrowband? I'm gonna go for higher data rates because I know that with 5G, like I remember when 5G was first coming out and they had like those crazy like narrowband 5G towers that would have like crazy download speeds, and I think it's because the band was narrower. So I'm gonna go for high data rates because that's the only thing I know that's correlated with a narrow band. Greater penetrating power, really? Really? But what about like a 2.4 gigahertz versus 5 gigahertz signal? Like, isn't 2.4 gigahertz better at penetrating through walls? Oh, so it's referring. That makes sense. What? It's not 1. Oh no, 2 and 4 are identical. Okay, I'm gonna go for 2, I guess. Okay, it was 4, which is identical. Whoops. Sometimes when I do this, it's a little difficult to catch when I accidentally have a distractor be the same as the answer. I'm actually gonna... it's fine. I was gonna change it, but it's fine. Ah. Right, because radius uses UDP. Whoops. It's over. What? Whoops. Right, okay. I'm gonna do a typing test.
my god.
I was doing so well. 118 is pretty good, though. Okay, I'm gonna try one more time. I don't think it'll be as fast, but you know. It's so over. I know I'm just going to disappoint myself, but I'm going to try one more time. Dude. Oh, sure. Hot standby router. I should just know this acronym and it would give me the answer to this question. Unforeseen consequences. Prepare for unforeseen consequences. Okay. 28 math, why can't you rely solely on the first 3 octets? 28 math. Good God, that's IPv6. Wait, what? Oh wait, no, it's not. It's 2. I think the correct answer is 2. I'm scratching my thigh right now. I think the correct answer is 2. Yeah. Snapshot type image? That's a weird thing to say. Snapshot type image? I have my hand on my water bottle for the record, and I put my chin on my hand. I forget exactly what the root bridge is, but I'm pretty sure you can't just forward stuff to it. Really? Okay. I don't even know what this question is referring to. I see. Okay, that makes sense. Power sum crosstalk? I know that crosstalk is when like signal from one like medium goes into another medium, like unintentionally, whether it be through like unshielded cabling or whatever. But power sum crosstalk, I don't know exactly what that is. I don't think it would be the difference because it says sum in it, right? So I don't think it's 4. I could be wrong though. It would be weird if it was the suitability of a cable, so I don't think it's 3. I don't necessarily think it's crosstalk on the transmit pairs at the receiver end, but that would make sense. So, well, I don't know if it would be total interference either, but it does say sum. I'm gonna go for 2, but I just could be wrong. It's 3, really. It refers to a suitability of a cable? How? I wonder if there's like a Wikipedia page on like power sum crosstalk. Can I watch this? Sure, I'll watch this.
Hello, this quick tutorial covers the power sum crosstalk field testing parameters, 2 of several that must be verified to ensure standards compliance for the installed link or channel. Let's begin with a definition of power sum crosstalk. Crosstalk measures the amount of signal sent over one pair in a cable that leaks or is detected on an adjacent pair. If there's too much leakage, it can affect signal integrity on the adjacent pair. In earlier days, network technologies such as 10 megabit Ethernet and 100 megabit Ethernet used only 2 pairs for signaling, one to transmit and one to receive, so crosstalk was measured on a pair-to-pair basis. At gigabit rates, however, all 4 pairs simultaneously transmit and receive. Therefore, the signal on any one pair can experience interference from the simultaneous, or power sum, leakage from the 3 other pairs. As shown here, when the crosstalk measurement is at the signaling source end, it's referred to as power sum near-end crosstalk or PS next testing. And since we're measuring the relative difference between the strength of 3 signals and the combined strength of their leakage, a higher decibel or dB value is better. It means that
What's the value of like subtracting the total strength of the 3 combined transmitted signals and then subtracting it by their leakage into the fourth pair. What's happening there? I guess that way you could measure, like, how much crosstalk is happening in the fourth pair. But, like, why would you want to do that? Because, like, why would a bunch of crosstalk be happening only in the fourth pair? Or is it just, like, relative to the other ones? And if so, like, would you loop up, like, would you recursively, if you're doing a cable test, would you recursively go over that? Like, send signals down all four, and then measure 3, and then subtract the crosstalk from the outlier from the total transmission of the 3, and then you do that on all 4. But what's the utility in that? I guess just to measure the crosstalk, right?
There's more signal energy and less leak energy. Let's now take a look at measuring power sum crosstalk at the destination end, or the far end, of the link or channel. Power sum crosstalk at the far end will always be lower on longer links or channels than on shorter ones, because of attenuation or insertion loss, which reduces the strength of any signal over the length of a cabling run. So, in order to provide a test limit applicable to every possible link or channel length, the power sum crosstalk calculation at the far end is adjusted for the attenuation measured on the link or channel. The resulting value is called the power sum attenuation to crosstalk ratio far end, or PSACR-F. We'll finish this module with a review of the published PS-Next and PSACR-F limits for categories 5E, 6, 6A, and 8. The applicable standard is the Telecommunications Industry Association, or TIA.
I'm gonna do 4.5 opus. Quad Opus 4.5 is so expensive, so I'm kind of curious how much this prompt will cost. I'm guessing maybe 3 cents. But I could be wrong, it could be more. It really depends on how many output, like, thinking tokens it creates. $0.02, okay. That is not what I mean. I mean like what's it called? Is it DBM? Okay. God, Opus is so expensive. You can really tell I'm bawling though because I'm using Opus for studying. The suitability of a cable. Okay. Yeah. Sorry, my dad came in my room. Bottleneck, right? Am I stupid? um... Oh, the first, I thought it meant like 0.1, not 0.0, right? Because 0.0 is the network address. Whoops. What am I, Lua? What am I? What am I, Brazilian? This is the I think I really messed up this question. Yeah. It's either 2 or 4, I feel like. Meantime, I don't know. 2? Okay. Okay, so you would have to do 0 shortening on the first part. Okay, it's definitely not 1. It's definitely not 4. So it's either 2 or 3. Wait, 2 and 3 are identical. Oh no. Oh god. I don't know, 3? Okay, 2. Remote network, VPN. High availability and redundancy for the network's first hop. You've been tasked implementing first hop redundancy protocol. Single virtual IP address as the default gateway for the subnet. I don't know. HSRP? VRRP. Okay. Reciprocal arrangements? Okay, it's not 1. Reciprocal implies mutual, so I don't think it's 2. So it's either 3 or 4. I'm gonna go for 4. Okay. Globally unique unicast IPv. Commonly referred to as 64, 48. Okay. Oh, sure, that makes sense because it's 48 bits long. Okay, 2. And then VRRP. And then 48 because it's 48 bits long. And then it's 12 for the network, and then 32 for the host, right? Use a wire map tester to evaluate the integrity of Ethernet cables in the office. One of the cables shows a problem with incorrect pin out, incorrect termination. The technician needs to identify the most likely cause of the issue. What is the most likely cause of the incorrect pin out, incorrect termination issue detected by the wire map tester? It's not 2. I don't think it's 1. It's got to be 3. Intrusion detection system defines a baseline of normal traffic that would be pattern anomaly based. What is a knowledge factor? That'd be a password. Encapsulating security payload. I'm pretty sure encryption of the payload only, right? Whoa, what? I'm going to do a typing test. 115 is pretty nice. I'm gonna try 15. What's my PB for 15? 118. I could definitely get past 118 for 15. Oh, maybe I can't. Maybe I can't. Maybe it's over. Maybe it's over for me. Maybe it's over. Maybe it's over. What's this about? Okay. No, which is kind of obvious. static files. Behind walls or through ducts. Solid. Dude. Sure. Wow, question 1000. I definitely haven't studied enough, but I might be kind of done studying, frankly. Yeah, okay.